Welcome back. Settle in. However you like to settle in. Find the softest part of your pillow. Pull the blanket a little higher, if that feels good. Let your shoulders drop just a little, away from your ears. You don't have to listen carefully tonight. You don't have to remember anything. You don't have to follow along. The words are only here to keep you company while you drift, like a quiet hand resting on the edge of the bed. Tonight, we are going somewhere very far away. Not so. Far that it feels strange, but far enough that the ordinary cares of the day cannot reach us there. We are going out past the moon, and past the warm, bright pull of the sun, and past the dry red plains of Mars, and past the great striped giant Jupiter, with its slow, swirling storms. We are going further still, into the colder dark, where the light from the sun grows thin and pale, and the stars seem closer than they really are. And there, hanging quietly in the long night of space, we will find a world that has been waiting for us, a world wrapped in pale gold and circled by 1,000 soft rings of ice, a world named Saturn. Let your breath grow a little slower. There is no rush at all. We have all night. The journey out to Saturn in real life would take many years. Spacecraft built by careful hands have taken 7, sometimes 8, sometimes 9 years to reach it, drifting on long curved paths across the solar system, taking little sips of gravity from the planets they passed. But we don't need to wait that long. We can be there in a single soft breath, in and out. And there it is, Saturn, hanging in the dark like a lantern that someone left lit in another room. Take a moment before we go any closer to notice how quiet it is out here. The thing about space, the thing that surprises people who have never thought about it, is just how silent it is. There is no air between the planets, and without air, there is no medium for sound to travel through. So the great storms on Saturn, the winds that race around the planet at over 1,000 miles an hour, make no sound at all that anyone could hear from out here. The grinding of the rings, all those countless small pieces of ice tumbling past each other, makes no sound. The flares of the distant sun, the bright plumes shooting up from Enceladus, the slow drift of Titan through its long orbit, all of it happens in absolute silence. Nothing here can be heard, only seen. And so it is a quiet place, this distant outpost of the solar system, a place where everything happens softly and slowly, and without any sound at all. You are safe here, of course. There is nothing to do. There is nothing to remember. There is no place you need to be, no message you need to answer, no question that needs an answer right now. Whatever you carried into this evening, you can set it down for a little while. The day is finished. The day's work is done. Whatever was difficult about today is finished, even if it does not feel finished yet. Whatever was good about today is finished too, and that is also all right, because there will be other good things tomorrow, and the day after, and the day after that. For now, there is just this, just the dark, soft space, just the gold-colored planet, hanging quietly in front of you, just the soft sound of your own slow breathing, in your own warm bed, in your own quiet room. Before we go closer, let me tell you a little about how the people of Earth came to know this world. Saturn has been watched from the gardens and rooftops and mountaintops of Earth for as long as there have been people who looked up at night. It is one of the 5 planets that can be seen with the naked eye. without any telescope, without any glass at all. Just a soft, pale point of light, the colour of old butter, moving very slowly against the patient stars. So slowly, in fact, that ancient sky watchers gave it the name of the Slow One. The Babylonians, who watched the heavens from the broad flat plains between two rivers, knew Saturn well. They wrote its movements on small clay tablets, pressing the marks into the soft clay with the cut end of a reed, and then leaving the tablets out in the sun to dry. Some of those tablets still exist today, 4,000 years later. The names of the people who wrote them are gone, the cities they lived in are quiet mounds of earth, but the careful little marks they pressed into the clay are still there, still telling us where Saturn was on a particular night, a long, long time ago. The watchers in ancient China kept their own quiet records of Saturn, calling it the Earth Star, because in their system of elements they associated it with the patient, steadying force of the soil. The watchers in ancient India gave it the name Shani, and they too thought of it as a slow and weighty figure, a being of careful judgment, taking his time to weigh each thing on its own merit. In nearly every culture that watched the night sky, Saturn was understood as the slowest of the wandering lights, the most thoughtful, the most measured, the one who could not be rushed. There is something true, even now, about that old understanding. Saturn moves at its own pace. It always has. It always will. The Greeks, looking at the same point of light, called it Kronos, after the old god of time. Kronos was an ancient figure older than the brighter, more famous gods, a quiet figure with a long beard, holding a curved blade, or sometimes a sheaf of wheat. He was a god of harvests, and of the slow turning of seasons, and of the long unhurried passage of years. The Romans, who borrowed many of their gods from the Greeks but gave them new names, called him Saturn, and it is from the Romans that we have inherited the name we still use today, Saturn. Even our word Saturday comes from this same root, the day of Saturn, the day at the quiet end of the week. So, when you say the name of this planet, you are saying something very old, something that has been said softly under the stars for thousands and thousands of years. For a long time, of course, no one knew that Saturn was a world. To the people of the ancient world, it was a wandering light, a small, careful traveller that moved against the patterns of the stars. The stars themselves were thought to be fixed in place, painted on the inside of a great dark dome that turned slowly above the earth. But a few of the lights wandered. They moved at their own pace, sometimes forward, sometimes seeming to pause, and sometimes even drifting backward against the dome of fixed stars before turning forward again. These wandering lights were called planets, from the Greek word for wanderer. There were 5 of them visible to the eye: Mercury, quick and shy, never far from the sun; Venus, the bright morning and evening star; Mars, the red one; Jupiter, large and steady; and Saturn, the slowest, the one who took the longest to make his way around the wheel of the sky. It was not until many centuries had passed that anyone thought to point a piece of curved glass at the sky and see what they could see. The first people to do this were a few patient craftsmen in the Netherlands in the early 1600s. They were not astronomers. They were spectacle makers, men who ground glass into smooth, round shapes, for people whose eyes had grown tired with age. By chance or by careful experiment, they discovered that two such pieces of glass, held one in front of the other at just the right distance, made faraway things appear close. They put their lenses into long tubes of leather and brass, and they called the new device a spyglass. It was meant for looking at distant ships or at flags on the towers of faraway towns. But news of the spyglass travelled as news does, and it eventually reached the ears of an Italian scholar living in the city of Padua. His name was Galileo. And Galileo, who was a very curious man, did something that no one before him had thought to do. He turned the spyglass upward. What he saw changed everything. The moon, which had always seemed to be a smooth, pale disk, was revealed to be a world of mountains and valleys and shadowed plains. The planet Jupiter, which had always seemed to be a single point of light, was revealed to have 4 small moons of its own, circling it in a careful dance. The Milky Way, which had always seemed to be a misty band of cloud across the sky, was revealed to be made of countless individual stars, more stars than anyone had ever imagined. And when Galileo turned his small, simple telescope toward the slow, pale point of light, called Saturn, he saw something stranger still. He saw that Saturn was not a single round planet the way the others appeared to be. Saturn seemed to have on either side of it 2 smaller round shapes, almost touching the planet itself. He could not quite make sense of what he was seeing. His telescope was not strong enough to show him clearly. He wrote in a letter to a friend that Saturn appeared to be a triple planet, 3 little worlds joined together. He drew a careful picture of what he saw, and the picture looks a little like the head and ears of a small round creature. For nearly half a century no one knew quite what to make of these strange ear-like shapes that seemed to come and go around Saturn. Sometimes the ears were there, plain to see. Sometimes they faded almost away, and Saturn appeared to be a simple round disk, like the other planets. Galileo himself was quite puzzled and grew rather frustrated. At one point, looking up at Saturn after a long absence, he found the ears had vanished entirely, and he wrote, with a kind of mock sorrow, asking whether Saturn had eaten his own children. It was a joke, really, a reference to the old myth of the god Kronos, who in the stories had swallowed his own offspring out of fear. But the puzzle of the disappearing ears would not be solved until a much later astronomer, a Dutchman named Christian Huygens, came along with a better telescope and a quieter mind. Huygens worked carefully, watching Saturn night after night, and at last he understood. The strange ears were not a feature of the planet itself. They were a thin, flat ring surrounding Saturn but not touching it, a ring of some bright material encircling the planet entirely. And the reason the rings sometimes appeared and sometimes seemed to vanish was simply this. Saturn is tilted on its axis, and so are its rings. And as Saturn moves slowly around the Sun on its long, unhurried orbit, the rings sometimes face us, full on, looking like a wide, pale platter, and sometimes turn edge-on to us, becoming so thin that they almost disappear. This was an extraordinary discovery, a planet with a ring around it. Nothing like that had ever been seen before, and for a long time afterward, Saturn was thought to be unique in the entire solar system, the only ringed world. We know now, of course, that the other gas giants have rings of their own, though they are far thinner and fainter and harder to see. But Saturn's rings are still by far the most beautiful and the most easily visible and the most extensive of any rings in the solar system. They are one of the great wonders of our cosmic neighborhood, and they will be the heart of our journey tonight. But before we draw close to the rings, let me tell you a little about Saturn itself, the world inside the rings, because Saturn, as a world, is very different from the Earth. Very different indeed. Saturn is what we call a gas giant. That is to say, it is a planet made not of rock and stone, the way the Earth is, but mostly of gas. If you tried to land a spacecraft on Saturn, there would be nothing to land on. You would simply sink gently at first into thin, pale clouds, and then into thicker clouds, and then into a strange, foggy region where the gas is squeezed so tightly that it begins to behave more like a liquid. There is no clear surface, no solid ground, no place where the atmosphere ends and the planet begins. It is gas all the way down, becoming denser and hotter and stranger the deeper you go. Saturn is enormous, truly enormous by the standards of any earthly thing. If you could somehow set the Earth and Saturn side by side, the Earth would be smaller than one of Saturn's storms. You could fit more than 700 Earths inside the volume of Saturn with room to spare. And yet, despite its great size, Saturn is not very heavy for its bulk. The material it is made of is so light, so airy, that the whole planet, taken together, is less dense than water. If you could find a bathtub large enough and you could somehow place Saturn inside it, the planet would float. It would bob gently on the surface, like an enormous pale apple. It is the only planet in our solar system about which this is true. Every other world, if you could fit it into a bathtub of imagination, would sink to the bottom. Only Saturn would float. The reason Saturn is so light, despite being so large, has to do with what it is made of. Saturn is made mostly of hydrogen, the simplest and lightest of all the elements, the same element that makes up most of the sun and most of the stars. About 96% of Saturn by mass is hydrogen. Most of the rest is helium, the second lightest element, the same gas that fills children's balloons and makes them rise toward the ceiling. There are smaller traces of other things mixed in, ammonia and methane and water, and a few other simple compounds, and these traces are what give Saturn its soft butter color, its pale gold and cream and quiet tan. But the planet is mostly hydrogen and helium, and these gases are so light that they make the whole great world less dense than the water in a glass. Saturn spins very fast. This is another thing that is strange and interesting about gas giants. Despite being so much larger than the Earth, Saturn rotates on its axis in only about 10.5 hours. A day on Saturn is less than half as long as a day on Earth. Because the planet spins so quickly, and because it is made of gas rather than solid rock, the rotation actually deforms the planet's shape. Saturn is not a perfect sphere. It bulges noticeably at the equator and is flattened at the poles. If you looked at it from far away, you would see that it is shaped a little like a soft, round stone that has been gently squeezed between two fingers. This is true of all the gas giants to some extent, but it is most noticeable on Saturn because Saturn's material is so light and so easily moved by the spinning. Although a day on Saturn is short, a year on Saturn is very long indeed. Saturn takes about 29.5 Earth years to make one trip around the Sun. Imagine that for a moment. A single year on Saturn is longer than the lifetime of many small things on Earth. A dog, a cat, a horse. By the time Saturn has gone once around the Sun, a child born at the start of that year has grown up, become an adult, perhaps started a family of their own. Whole eras of human history can pass within a single Saturnian year. The first human being ever to step on the surface of the Moon, Neil Armstrong, was born in 1930. Saturn, on that day, was somewhere in its orbit, drifting slowly through the constellation of Capricornus. By the time Saturn had finished a single one of its long orbits and returned to that same patch of sky, Armstrong was nearly 40, had walked on the Moon already, and was returning to ordinary life. Saturn, all that while, had simply made one quiet circle. Because Saturn takes so long to orbit, and because it is tilted on its axis at about 26.5 degrees, similar to Earth's tilt, Saturn has seasons. But the seasons on Saturn last about 7.5 Earth years each. Imagine a winter that lasts 7 years. Imagine a summer that goes on for the whole length of an ordinary childhood. The seasons on Saturn change very gradually. The pale gold colours of its clouds shift slowly over the course of decades as one part of the planet leans toward the distant sun and the other part leans away. Astronomers on Earth, watching Saturn carefully through their telescopes, can see these seasonal changes. The northern half of the planet may take on a faintly bluer tint during its long winter, when less sunlight reaches it, and a paler gold during its long summer, when the sun shines on it more directly. These are subtle changes, hard to notice in any single year, but unmistakable when you compare photographs taken decades apart. The rings too change with Saturn's seasons in a sense, because the rings are tilted along with the planet. They sometimes face Earth at a steep angle, looking from our distant vantage like a wide flat platter, fully open, glittering at us in their entire breadth. And sometimes, every 15 Earth years or so, halfway through Saturn's long year, the rings turn edge on to us and become so thin from our point of view that they nearly vanish. For a few months at a time, Saturn appears almost ringless from Earth. Then slowly the rings open up again and grow wider and fill the view, and Saturn resumes its familiar appearance as the most beautiful planet in the sky. This is the phenomenon that confused Galileo so much all those centuries ago when he watched the strange ears of Saturn appear and disappear without explanation. The fast rotation combined with the planet's deep cloudy atmosphere creates beautiful patterns in Saturn's outer layers. If you look at Saturn through a good telescope, or in the photographs sent back by spacecraft, you can see that the planet is wrapped in soft, horizontal bands, pale stripes of cloud running parallel to the equator in shades of cream and butter and faint amber. These bands are caused by enormous winds blowing in opposite directions, racing around the planet at tremendous speeds. The strongest of these winds, near Saturn's equator, blow at over 1,000 miles per hour, faster than a jet plane, faster than a bullet. They have been blowing this way for as long as anyone has watched the planet, and there is no reason to think they will ever stop. Within these soft bands of cloud there are sometimes storms, large slow storms drifting along like pale islands. Most of these storms are small by Saturn standards and last only a few weeks or months, but every now and then, perhaps once in a generation of human lifetimes, a truly enormous storm appears. These are called the Great White Spots. They begin as a small bright blossom in the planet's northern half, and they grow and grow, and within a few months they wrap themselves around the entire planet, forming a great pale band that circles all the way around the world. One of these great white spots was observed in 1876, another in 1903, another in 1933, another in 1960, another in 1990. They seem to come at intervals of about 30 Earth years, which is roughly the length of a single year on Saturn, as if the planet itself were taking one long, slow breath and exhaling once each time it makes its way around the sun. There is one feature of Saturn's atmosphere that is so strange, so unexpected, that it is worth pausing on for a moment. At Saturn's north pole, there is a hexagon, a six-sided shape drawn in the clouds, like something a careful child might trace on a window pane. It is enormous. Each side of the hexagon is longer than the diameter of the Earth, and it has been there, holding its shape, for as long as we have been able to see it clearly. Spacecraft photographed it in the early 1980s, and it was still there, in the same place, in the same shape, when other spacecraft photographed it again 20 years later, and again 30 years later. It does not move, it does not drift, it does not break apart and reform. It simply persists, a great six-sided ring of cloud slowly turning at the top of the world. No one is entirely sure why the hexagon exists. The lead-in idea is that it has to do with the way certain wind patterns interact. When they flow at the right speeds in the right directions around the pole. Scientists have tried to recreate the shape in laboratories using spinning tanks of fluid, and they have found that under just the right conditions, you can sometimes coax a fluid into making polygonal patterns, six-sided ones like Saturn's hexagon. So it is probably just physics, just the patient mathematics of moving air. But it does not feel like just physics. When you look at it, it feels like something that someone somewhere drew very carefully a long time ago and then quietly walked away. Now let us go a little deeper, down through Saturn's pale clouds, down past the storms and the hexagon and the racing winds, down into the strange, dark interior of the planet. The further down you go, the warmer it gets, and the more tightly the gas is pressed together. Eventually, the hydrogen becomes so squeezed that it starts to behave in unusual ways. It becomes a liquid, first an ocean of liquid hydrogen, deep and dark and nothing like any ocean on Earth. And then, deeper still, the pressure becomes so extreme that the hydrogen begins to behave like a metal, liquid metallic hydrogen. It can carry electric currents the way the metals in a copper wire can carry electric currents. And it is the slow, swirling movement of this liquid metallic hydrogen deep inside Saturn that gives the planet its enormous magnetic field. Before we go any further into the planet's interior, it might be worth thinking for a quiet moment about how Saturn came to exist at all. Where does a planet like Saturn come from? How does such a great soft world assemble itself in the dark? The story begins about 4.5 billion years ago, in a great cloud of gas and dust drifting through one of the spiral arms of our galaxy. The cloud was vast and quiet and very cold. It had probably been drifting for a long time, slowly turning, slowly thinning out in some places and gathering itself together in others. And then, perhaps from the shock wave of a nearby star exploding, perhaps from some other gentle nudge, parts of the cloud began to collapse inward upon themselves. Gravity, that patient and unceasing force, drew the gas and dust together into a slowly spinning disk. At the very centre of the disk, the material grew dense and hot, until at last it ignited and became a star. That star was our sun, and around the new young sun the rest of the disk continued to spin and to gather and to organize itself. In the warm inner regions of this disk, close to the sun, only the rocky and metallic materials could survive the heat. The lighter gases were blown away by the strong young winds of the new star. So the inner planets, when they formed, were made of rock and metal, Mercury, Venus, Earth, Mars, small dense worlds with thin atmospheres or none at all. But further out in the disk, beyond a certain distance, it grew cold enough for ices to remain, water ice, ammonia ice, methane ice. And there, in the colder outer reaches, planets had much more material to work with. They began to grow large and quickly. Saturn was probably one of the first planets to begin forming, perhaps around the same time as Jupiter, perhaps a little later. Once Saturn had gathered enough rock and ice to form a substantial core, its gravity was strong enough to begin pulling in great quantities of the surrounding hydrogen and helium gas. And so the planet ballooned outward, gathering more and more gas onto itself, growing into the enormous, soft world we see today. The whole process, from the first stirrings of the cloud to the rough completion of the planets, probably took only a few tens of millions of years. By cosmic standards, this is very fast. The solar system that we see today, with its 8 planets and their moons and their rings, was largely in place by about 4.5 billion years ago. Saturn has been drifting in roughly its current orbit, doing roughly what it does today for nearly the entire age of the solar system. Generations of stars in our galaxy have lived and died while Saturn has gone on with its quiet turning. Civilizations have risen and fallen on Earth. Continents have drifted across the face of our world. The dinosaurs came and went. Forests grew and burned and grew again. And throughout all of this, Saturn has simply continued to turn in its long, slow orbit, in its pale gold quiet, completely unaffected by any of it. There is something peaceful about this. Some things in this universe are very steady. Saturn is one of them. Whatever happens, whatever trouble there is on the small blue planet where you are listening to this, Saturn will go on, the rings will go on turning, the clouds will go on drifting, the hexagon will go on holding its strange six-sided shape. None of it depends on us or on anything we do. It is simply there, doing what it has always done, and what it will go on doing for a very long time still. Saturn has a magnetic field similar in some ways to the Earth's, but much larger. It reaches out into space for hundreds of thousands of miles, forming an invisible bubble around the planet that protects the inner regions from some of the harshness of solar radiation. Within this magnetic field, charged particles from the Sun can become trapped, and they sometimes spiral down toward the planet's poles, where they collide with the upper atmosphere and create soft, glowing curtains of light, very much like the auroras we see at the poles of the Earth. Saturn has its own auroras in pale violet and ghostly gold, dancing slowly above its north and south poles. At the very heart of Saturn, deeper than the metallic hydrogen ocean, deeper than anything else, there is thought to be a small, dense core, made of heavier elements, rock, perhaps, and ice and metals, all squeezed together by the enormous weight of the planet above. The core is quite small by Saturn standards, perhaps the size of the Earth or a little larger, but it is many times more massive than the Earth because it is so densely packed. We cannot see this core, we cannot send any instrument down there to look at it directly. The pressure is too great, the heat is too fierce, and the journey would crush any spacecraft long before it arrived. We know about the core only because we can measure the way Saturn's gravity behaves, and from that we can work out, with patient mathematics, what must be inside. Now let us drift back up, gently, out through the metallic hydrogen and the liquid hydrogen ocean and the dark, warm clouds of the deep atmosphere and the colder pale clouds of the upper atmosphere, and out into the clear, empty space above the planet. And here before us are the rings. The rings of Saturn are made of countless small pieces of ice, mostly water ice, the same stuff that makes up the ice cubes in a freezer or the snow on a winter morning, but here in space the pieces are tumbling slowly through the dark, each one in its own quiet orbit around the planet. The pieces vary in size enormously. Some are smaller than grains of sand, no bigger than the dust that gathers in the corner of a windowsill. Some are the size of pebbles or marbles or small stones. Some are the size of houses. A very few are as large as small mountains, but most of them are quite small, the size of a fist or smaller. There are unimaginably many of them, trillions upon trillions of small icy pieces, all drifting along together in their long flat plane around the planet. When you look at the rings from far away, they appear smooth like a great solid disk. But this is only because there are so many small pieces, and they are so close together, and our eyes cannot pick them out individually from such a distance. If you were close to the rings, you would see that they are not solid at all. You would see a vast scattering of little white snowballs drifting slowly past one another, each one shining gently in the pale sunlight, each one in its own careful orbit. It would feel a little like being inside an enormous slow-motion snowstorm, except that the snowflakes never fall, never melt, never settle. They just keep tumbling along year after year, century after century, age after age. Each piece of ice has been doing exactly what it is doing now for an unimaginably long time. Each piece will go on doing it in all likelihood for a very long time still. There is a kind of patience in the rings that is hard to put into words. They are not waiting for anything. They are not on their way to anywhere. They are simply turning and turning and turning in the soft, cold light of the distant sun. The rings are extraordinarily wide and yet extraordinarily thin. They reach out from Saturn for nearly 170,000 miles, which is far enough that you could fit nearly 20 Earths side by side across them. But they are very thin indeed. In most places, the rings are only about 30 feet thick, less than the height of a tall tree, less than the height of a small house. If you imagine taking a piece of paper an ordinary sheet of writing paper, and cutting it into the shape of a wide, flat disk, the proportions would be roughly right. The rings of Saturn are like a sheet of paper laid out to a width of 200,000 miles. They are one of the flattest things in the entire solar system. The rings are not all one continuous sheet, however. They are divided into several main sections, separated by gaps. The earliest astronomers, peering through their small telescopes, could see only the brightest and broadest of these divisions. They named the main rings using letters of the alphabet in roughly the order in which they were discovered. The brightest and easiest to see were called the A ring and the B ring. The fainter, dusty ring closer to the planet was called a C ring. There is also a D ring, very faint, very close to the planet's cloud tops, and further out, beyond the bright main rings, there are the F ring, the G ring, and the broad, faint E ring, each one a little fainter than the last, each one a little dustier and more spread out. Between the A ring and the B ring, the two brightest rings, there is a wide, dark gap. This gap was first noticed in 1675 by an astronomer named Giovanni Cassini, working at the Paris Observatory. The gap is now called the Cassini Division, in his honour. From Earth, it appears as a thin, dark line cutting across the bright disk of the rings, but in fact, the Cassini Division is more than 2,000 miles wide enough to fit a continent. The reason for this gap, and for the other smaller gaps in the rings, has to do with the gravitational influence of Saturn's moons. Particles that try to orbit within the gap end up being nudged, again and again, by the tug of one moon or another, until they are eventually flung out of that orbit and into a different one. So the gaps are kept clear, swept clean by the patient pulling and pushing of Saturn's many moons. When spacecraft flew close to Saturn in the late 1970s and again in the 1980s, and again much more recently, they discovered that the rings are far more complex than anyone had imagined. What had appeared from Earth to be a few smooth bands turned out to be made of thousands upon thousands of narrow ringlets, like the grooves on an old vinyl record. Some of the ringlets are slightly brighter than others. Some have wavy edges, where the gravity of nearby moons has rippled the ice into careful patterns. Some of the ringlets twist and braid around each other in strange ways, especially the F ring, which is the narrowest and most peculiar of the rings. The F ring is held in place by two small moons, one on either side of it, called Prometheus and Pandora. These two moons are shepherd moons. They herd the icy particles of the F ring back and forth, keeping the ring narrow and contained, like two patient sheepdogs working a flock of sheep. There are still other features in the rings that are stranger still. There are spokes, dark radial streaks that sometimes appear across the B ring, lasting for a few hours and then fading away. They were first seen in photographs taken by a spacecraft called Voyager 2 in 1981, and no one had expected them. Their cause is thought to be related to electrical charges in the dust lifted briefly above the plane of the rings. There are also tiny propeller shapes, small disturbances in the ice caused by miniature moons that are too small to see directly, but whose presence shows up in the wakes they leave behind. There are scalloped edges and waves and clumps that gather and scatter and gather again. The rings are not still, they are quietly, patiently alive with motion. How old are the rings? This is a question that astronomers are still trying to answer. For a long time, it was thought that the rings might be very old indeed, perhaps as old as Saturn itself, which would make them about 4.5 billion years old. But more recent measurements have suggested something else, something stranger. The rings, by some calculations, might be much younger. They might have formed only 100 million years ago, or perhaps 200 million. Which means that if you walked the Earth at the time of the early dinosaurs, and if you had a powerful enough telescope, you might not have seen rings around Saturn at all. The dinosaurs, in their long quiet age of fern and warmth, may have lived under a sky in which Saturn was a plain, ringless world, like Jupiter, and only later, perhaps when some small icy moon drifted too close to Saturn and was pulled apart by the planet's tides, did the rings come into being. A young feature, by cosmic standards, a passing decoration. The rings, beautiful as they are, may not last forever. They may slowly drain away into Saturn's atmosphere, or scatter into space over the course of the next 100 million years, or perhaps a few 100 million more. We are lucky to be here in the time of the rings. We are lucky to look up and see them. Let us pause here and imagine something that could not really happen, but that is interesting to imagine all the same. Let us imagine that you could fall through Saturn from the very top, where the atmosphere is thin and cold, all the way down to the small, dense core at the heart of the planet. What would the journey be like? Not that anyone could ever truly make it, because the pressures and heats deeper down would crush and burn any traveller long before they arrived. But if you could, if you somehow could, what would you see? At the top, where you began, the air would be very thin and very cold. Cold enough that any moisture in your breath would freeze instantly into tiny crystals. The temperature near the cloud tops of Saturn is somewhere around minus 140 degrees Celsius, far colder than the coldest winter night in any place on Earth where people live. The light here would be soft and pale, the sun a distant bright spot in a black sky, the stars still visible all around even in the daytime. You would see the rings edge on if you were near the equator, glittering off in the distance like a vast, bright knife laid across the sky. As you fell, you would pass through the highest layer of clouds, which are made of ammonia ice. Tiny crystals of frozen ammonia drifting in the cold, thin air, giving the upper atmosphere its pale white colour. These clouds are similar in some ways to the high cirrus clouds of Earth, the thin, wispy ones that ride at the very top of our own atmosphere. Below the ammonia clouds, you would enter a thicker, slightly warmer layer, where the clouds are made of ammonium hydrosulfide, a compound that gives Saturn's atmosphere some of its yellow and tan colour. Below that, deeper still, you would pass through clouds of water ice, and then perhaps clouds of liquid water droplets, similar in some ways to the rain clouds of Earth, but mixed with ammonia and other compounds. Below the cloud layers, the atmosphere would grow steadily denser and warmer and stranger. You would no longer be falling through anything that resembled air. You would be falling through a thick, warm soup of hydrogen and helium gas, growing thicker with every mile. The pressure would build, the temperature would rise. Eventually, at a depth of perhaps 15 or 20,000 kilometers below the cloud tops, The gas would have become so dense that there would no longer be any meaningful difference between gas and liquid. You would simply be in a great hot ocean of hydrogen with no surface, no shore, no boundary at all. The temperature here would be hotter than the surface of many cooler stars. The pressure would be hundreds of thousands of times what we experience at sea level on Earth. Deeper still, perhaps 30,000 kilometers down, the pressure would reach the strange threshold at which hydrogen becomes a metal. The whole vast interior of Saturn, from this depth all the way down toward the core, is filled with this metallic hydrogen, a substance that does not exist anywhere on Earth, and that we can only study in tiny experiments inside laboratories. It is a shimmering, conductive liquid, hot and dense beyond anything we usually imagine, and it is in the slow, swirling currents of this metallic hydrogen, churned by the heat from the core and the rapid spinning of the planet, that Saturn's magnetic field is generated. Finally, deep at the very heart of the planet, you would arrive at the core, a small dense ball of rock and ice and heavier elements, perhaps twice the size of the Earth, but many times more massive, because everything inside it has been pressed together by the enormous weight of the planet above. The core is hot, perhaps 11,000 degrees Celsius, hotter than the surface of the Sun. It has been hot since Saturn first formed, and it is slowly losing that heat into space, but it is so well insulated by the great soft envelope of gas around it that the cooling happens very, very gradually. Saturn will continue to release this primordial heat for billions of years still. In fact, Saturn radiates more energy out into space than it receives from the Sun. Some of this is leftover heat from its formation, and some of it, scientists believe, comes from a slow rain of helium droplets falling through the metallic hydrogen, releasing energy as they fall. A strange thought that, deep inside Saturn, there is a kind of helium rain falling silently through a metal sea in the dark forever. Of course, no one will ever make this journey. The pressures are too great, the heat too fierce. Any object that fell into Saturn would be torn apart and vaporized long before it reached the core. The spacecraft Cassini, when it took its final dive into Saturn at the end of its mission, lasted only about a minute or two before it was destroyed by the heat and pressure of the upper atmosphere. The rest of its descent into the deeper layers of the planet would have happened to a cloud of vapor, not to a spacecraft. So all of this, the long, slow, imagined fall through Saturn, is just a story we can tell, a way of picturing the unimaginable, an exercise in quiet wondering. We are lucky to be here in the time of the rings. We are lucky to look up and see them. There is one more thing about the rings that is worth resting on before we move along. The rings make music. Not music that anyone could hear with their ears, of course, because there is no air around the rings to carry sound, but music in the sense of patterns, of resonances, of relationships between numbers and motion that are very much like the patterns that govern the strings of a musical instrument. When a guitar string vibrates, it does so at certain particular frequencies and not at others. There is a fundamental note, and there are overtones above it, and the relationships between these notes are governed by simple ratios: 2 to 1, 3 to 2, 4 to 3. The same kinds of relationships govern the orbits of objects in Saturn's ring system and the orbits of Saturn's moons. A piece of ice in a particular orbit takes a certain amount of time to go around Saturn. A nearby moon takes a different amount of time. If those two times are in a simple ratio, like 2 to 1, then the moon and the piece of ice will line up in their orbits at the same place, again and again, and the small repeated tug of the moon's gravity will gradually push the piece of ice out of that orbit. This is called an orbital resonance, and it is the reason for many of the gaps in the rings. The Cassini Division, for example, was carved out by a resonance with the moon Mimas. Particles trying to orbit in the Cassini Division feel a regular nudge from Mimas again and again on every other orbit, and over time they are swept out of that region and into other orbits. In a sense, the whole ring system is playing a complicated piece of music, a great mathematical symphony of orbits and resonances and harmonies. The moons are the conductors, the pieces of ice are the notes. The result, written in the patterns of the rings, is something a little like sheet music. If you knew how to read it, you could trace in the very arrangement of the rings the influence of every moon that has ever shaped them. The narrow gap here, drawn by Pan, the wavy edge there, drawn by Daphnis, the long swept-out emptiness of the Cassini Division, drawn by Mimas, the tightly contained F-ring held by Prometheus and Pandora. Every feature has a story. Every story is a relationship. Every relationship is a kind of song. It is not a fast song, it is the slowest song imaginable. A single note in the Song of the Rings might take days to play. A single phrase might take years. The whole symphony, from beginning to end, might take longer than the age of human civilization. But it is being played all the same, right now, while you rest. The conductors are conducting, the notes are sounding, the mathematical music of Saturn is going on and on and on, with no audience but itself. But Saturn is more than just a ringed planet. Saturn is also a small system in its own right, a planet surrounded by a great many moons, drifting at their own quiet distances, each one a little world. Saturn has at least 146 known moons, more than any other planet in the solar system. Most of them are very small, only a few miles across, irregular in shape, looking more like rough potatoes than like proper round worlds. They are probably captured asteroids or fragments of larger moons that broke apart long ago. But a few of Saturn's moons are large and round and worlds in their own right, with histories and surfaces and stories. And of these, the most remarkable is a moon called Titan. Titan is the second largest moon in the entire solar system. Only Jupiter's moon Ganymede is larger, and only just. Titan is bigger than the planet Mercury. It would be, if it were not in orbit around Saturn, perfectly large enough to be considered a planet on its own. And Titan is unique among all the moons in the solar system because it has a thick atmosphere, a real, dense, weather-having atmosphere. Most moons in the solar system have no air at all. Their surfaces are exposed directly to the vacuum of space. But Titan has air, thick orange-tinted air, denser even than the air on Earth. If you stood on the surface of Titan, the air pressure pushing on you would be about 1.5 times what it is at sea level on Earth. The air is mostly nitrogen like our own, but it is mixed with methane and other simple organic compounds, and these give the atmosphere a hazy, smoggy character, a soft golden gloom that hides the surface from view. For a long time, no one knew what was beneath Titan's hazy clouds. The cameras on the early spacecraft could not see through. It was only when a small probe called Huygens parachuted down through Titan's atmosphere in 2005 that we finally saw what was there. The probe sent back pictures during its descent and after it landed of the strange surface below. The Huygens probe is, in some ways, one of the most remarkable small machines ever built. It was about the size of a large, round dinner plate, weighing only a few £100. It had been carried all the way from Earth attached to the side of the larger Cassini spacecraft, and it had ridden quietly for 7 years, sleeping through the long journey, waiting for its moment. When Cassini arrived at Saturn and entered orbit, Huygens detached from its parent spacecraft and drifted alone for 3 weeks, on a careful trajectory that would take it directly into Titan's atmosphere. It was the first probe ever sent to land on a world in the outer solar system, the first object made by human hands ever to touch the surface of a moon other than our own. When it entered Titan's upper atmosphere, Huygens was travelling at about 12,000 miles per hour. A large heat shield protected it as the air friction slowed it down. Then, as the speed dropped, parachutes opened, slowing it further. The descent took about 2.5 hours. During those 2.5 hours, the probe took pictures and made measurements and sent everything back through the atmosphere, up to the Cassini spacecraft far overhead, which relayed the signals across space to listening antennas on Earth. The pictures came back, slowly, of a strange and beautiful landscape, drainage channels cut into pale hills, smooth dark plains that might have been the beds of long-dried lakes, the texture of frozen ground at very close range just before the probe touched down, and then a final image taken by the probe sitting still on the surface, showing a flat plain scattered with rounded pebbles of water ice, the size of grapefruits, the size of small stones. Water ice rounded and worn smooth, scientists believe, by the slow tumbling action of liquid methane streams that may have run across the surface long ago, or perhaps still run there, just out of sight. The probe was only built to last for about 30 minutes after landing on the small store of battery power it carried. It actually managed to keep transmitting for a little over an hour, sending back data from the surface of Titan, the only data ever gathered from the actual ground of any moon other than our own. And then, when the batteries finally gave out, Huygens fell silent and went still, and there it remains today, a small, quiet machine sitting on the cold orange-tinted surface of Titan, frozen in place forever. It will never be retrieved, it will never be visited. It will simply sit there, slowly being covered, perhaps, by the soft drift of organic dust from Titan's hazy sky, or perhaps by an occasional rain of liquid methane. A small monument to the curiosity of the people who built it, a quiet reminder that we are a species that sends our best work to faraway places just to see what is there. And later observations from above made with radar that could see through the haze revealed something extraordinary. There are on Titan lakes and seas of liquid, real lakes, real seas, with shorelines and inlets and rivers running into them. But they are not made of water. The surface of Titan is far too cold for liquid water. Water on Titan is frozen as hard as rock. The lakes and seas of Titan are made of liquid methane and liquid ethane, the same simple chemicals that make up natural gas on Earth. There it pools in great cold lakes, gently lapping against shores of frozen water ice, while a soft methane rain sometimes falls from the orange sky. The largest of these seas is called Kraken Mare, a name borrowed from old sailors' stories about a great sea creature that was said to lurk beneath the waves of Earth's oceans. Kraken Mare is enormous. It is larger in surface area than the Caspian Sea, the largest enclosed body of water on Earth. There are other seas too, with names drawn from old myths and legends. Ligeia Mare, named after a siren of Greek mythology. Punga Mare, named after a creature from the stories of New Zealand's Maori people. Each one is a great cold body of liquid methane lying still in the dim orange light, with rivers and streams of more methane running into it from the surrounding lands. If you could somehow stand on the shore of one of these methane seas, dressed in some impossible suit that could keep you warm and breathing in such a cold, strange place, what would it be like? The light would be very dim. Even at noon on Titan, the surface receives only about 1% as much sunlight as the surface of Earth does at noon. It would feel like a very deep twilight. The orange haze in the sky would prevent you from seeing the sun directly or from seeing Saturn, even though Saturn would be hanging quite large in the sky just above you. The whole sky would simply be a soft, uniform orange, like the inside of a great pumpkin. The ground beneath your feet would be hard and pale, made of water ice, but the ice would be so cold that it would be more like rock than like the ice we know on Earth. You could swing a hammer at it and it would chip like granite, not crack like a frozen pond. There would be small dunes of dark sand here and there, but the sand would not be made of crushed rock the way Earth's sand is. It would be made of frozen organic compounds, the sticky tar-like residue of methane that has been broken apart and reassembled by sunlight in the upper atmosphere over many ages. The methane sea before you would lie very still because Titan's gravity is low, only about 1/7 of Earth's, and its atmosphere is thick, and so any waves on the methane lakes are very small and slow. They would lap at the shore as if in slow motion. If a soft methane rain were falling, the drops would be much larger than rain on Earth, but they would fall much more slowly, drifting down through the thick air like flakes of snow, rather than streaks of water. You could probably watch a single raindrop fall for many seconds before it touched the ground. The temperature would be about -179 degrees Celsius, cold beyond anything in human experience. At such a temperature, the rules of chemistry begin to feel different. Things that are gases on Earth become liquids on Titan. Things that are liquids on Earth become rock-hard ice. The air you would breathe, if you somehow could, would not be breathable air at all. It would be a thick mixture of nitrogen and methane with no oxygen. It would smell, perhaps, faintly like natural gas, that warning scent that is added to the gas we use in our kitchens at home. But you would not smell anything because you would be inside your impossible suit, and the suit would be doing its impossible work of keeping you alive. What you might do on this strange shore is simply look out across the still orange sea. Look at the slow drift of small clouds far overhead. Look at the soft, rounded shapes of the icy hills in the distance. Listen to the hush, because Titan, despite its thick atmosphere, would still be a very quiet place. The methane wind would be soft. The methane rain would be soft. The lapping of the methane sea against the icy shore would be soft. Everything would be muffled and patient and slow. This is a place that has been here for billions of years. The methane lakes have not always been exactly where they are now. They probably move slowly over the long ages of Titan's history. Methane on Titan is in a long, slow cycle, similar in some ways to the water cycle on Earth, but stretched out over much greater spans of time. Methane evaporates from the lakes and rises into the sky and drifts there for a while and is broken apart by sunlight and sometimes recombines and eventually falls again as rain. The cycle is not quite balanced. Slowly, very slowly, Titan is losing its methane to space, where the lighter molecules drift away into the wider solar system. In a billion years or so, perhaps less, Titan may have no methane left, and the seas will dry up, and the sky will clear, and the strange weather of Titan will come to an end. But for now, it is still here, still raining its soft methane rain, still pooling in its great cold seas, still being watched from a distance by the eyes of any spacecraft we send to look. Titan is the only place in the solar system other than Earth where stable bodies of liquid have been found on the surface. Titan has weather. Titan has a hydrologic cycle, just like Earth, except that on Titan it is methane that evaporates from the lakes and rises into the sky and forms clouds and falls back to the surface as rain and runs in rivers and pools in lakes again. It is a strange echo of Earth, played in a different key, a world running on a colder and slower scale, the same patient music of evaporation and rainfall and rivers running to the sea. And there is more about Titan that is interesting still. Beneath the surface, beneath the layer of frozen water ice that makes up Titan's crust, scientists believe there is an ocean. A real liquid water ocean kept warm enough to remain liquid by the heat of Titan's interior and by salts and other compounds dissolved in the water that lower its freezing point. This subsurface ocean is one of the places in the solar system that some scientists think might possibly be a home for life. Not life like ours, not plants, not animals, not anything that would look familiar, but perhaps simple microbial life, drifting in the dark salt water beneath the ice, far from the orange sky and the methane lakes above. We do not know if it is there. We may not know for a very long time, but the possibility is there, hanging quietly above the question, like a soft light in another room. Titan is not the only moon of Saturn that may hide an ocean beneath an icy shell. There is another, much smaller moon called Enceladus, which is in some ways even more remarkable. Enceladus is small, only about 300 miles across, smaller than the country of France. It is round and white and shines very brightly, because its surface is covered in fresh, clean water ice that reflects almost all the sunlight that falls on it. Enceladus by surface is the brightest object in the entire solar system, brighter by reflection than freshly fallen snow. For a long time, Enceladus seemed to be just another small icy moon among many. But when the spacecraft Cassini flew close to it in 2005, the cameras saw something extraordinary. There were tall plumes of vapor rising from the south pole of Enceladus, shooting hundreds of miles up into space. Geysers, real geysers, on a small icy moon. The plumes were made of water and ice crystals and various dissolved chemicals, and they were coming up from beneath the surface through long cracks in the ice that scientists called the tiger stripes. The presence of the geysers meant that there was, beneath the icy shell of Enceladus, a body of liquid water. Warm water, kept liquid by some source of internal heat. A subsurface ocean. Cassini, on later flybys, actually flew through the plumes themselves and tasted them, in a sense, with its instruments. The plumes contained water, of course, and salts and silica grains, and traces of organic molecules, and small amounts of hydrogen gas. The presence of hydrogen in particular was very interesting. On Earth, we know that there are creatures deep in the dark seas, around hydrothermal vents at the bottom of the ocean, that live entirely on a kind of chemistry that uses hydrogen gas. They do not need sunlight, they do not need plants. They live by a slow, patient chemistry, eating the energy that comes up from the warm rocks beneath the seafloor. Whether such creatures might also live in the ocean of Enceladus, no one yet knows. But the chemistry there is very promising, very interesting indeed. Enceladus is one of the most likely places outside of Earth where life might possibly have taken hold. A small, bright, snow-white moon with a hidden warm ocean beneath and tall fountains of vapor rising silently into the dark. There are other moons of Saturn that are interesting in their own quiet ways. There is Mimas, which is small and grey and scarred by an enormous crater that makes the moon look strikingly like a certain famous battle station from a popular series of films. The crater is so large in proportion to the moon that scientists have wondered how Mimas managed to survive the impact that made it. Any harder a blow, and the little moon might have been shattered into pieces. As it was, Mimas was left with a great round dent on one side, and the rest of the moon intact, drifting on around Saturn as if nothing much had happened. There is Iapetus, a strange two-toned moon, with one side that is brilliantly white and another side that is pitch black, dark as soot. The boundary between the two is sharp and clear, as if someone had taken a brush and painted half the moon in dark ink, while the other half remained pure snow. The dark material is thought to have been swept up by Iapetus as it travels through space like a dusty windshield, collecting gunk. There is also a strange ridge of mountains running along the equator of Iapetus, a tall, thin spine that wraps most of the way around the moon. The cause of this ridge is still not fully understood. It looks almost as if someone had tried to give Iapetus a seam, sewing the two halves together at the equator. There is Hyperion, which is shaped like a sponge, irregular and porous, full of strange dark pockets and craters that look almost spongy when you see them up close. There is Phoebe, far out, orbiting Saturn in the wrong direction, suggesting that it is probably a captured object from the outer solar system, perhaps a wandering body that drifted too close to Saturn long ago and was pulled into orbit and never escaped. There is Pan, a small moon shaped exactly like a flying saucer, with a bulging ridge around its equator, formed by ring material that gathered on its surface as it swept through one of the gaps in the rings. There is Atlas, similarly shaped, like a small soft pastry, also a little ring-gatherer in its own quiet way. There is Tethys, a moon of bright water ice, with an enormous valley running across nearly 3/4 of its surface, a long curving canyon called Ithaca Chasma, deep and pale and old. Tethys also bears a great crater on one side, called Odysseus, almost as large in proportion to the moon as the famous crater on Mimas. Looking at Tethys, you have the sense of a small world that has been struck many times in its long, quiet life and has somehow held itself together, scarred but patient. There is Dione, a little larger than Tethys, with a strange feature on one side of it called the wispy terrain. From a distance, the wispy terrain looks like fine, pale streaks across the moon's surface, almost as if someone had brushed a soft white paint across the dark ice. When the spacecraft Cassini came close, it could see that the wisps are actually long, bright cliffs, places where the icy crust has cracked and shifted, exposing fresher ice beneath. Dione also has a thin, tenuous atmosphere of oxygen, far too thin to breathe, but interesting all the same. A small world, with a faint, quiet whisper of an atmosphere of its own. There is Rhea, the second largest of Saturn's moons after Titan. Rhea is round and grey and heavily cratered, an old, quiet surface that has been receiving impacts for billions of years, without much else to disturb it. There is some evidence, faint but interesting, that Rhea may have very thin rings of its own, a small set of dust particles in orbit around the moon. If this is confirmed, Rhea would be the only moon in the solar system known to have rings of its own. A moon with rings around a planet with rings around a star. It would be a charming nesting of small worlds inside larger ones. There is Helene and Telesto and Calypso, all small companion moons that share orbits with the larger moons, drifting along ahead or behind them at the gravitationally stable points where everything balances out. There are dozens of other tiny, irregular moons far out in the dark, some of them only a few miles across, each one with its own slow path around the gold-coloured planet at the centre of it all. For 13 years, between 2004 and 2017, all of this was watched closely by a single remarkable spacecraft. But Cassini was not the first spacecraft to visit Saturn. 3 earlier robotic visitors had passed through the Saturnian system before Cassini ever arrived, each one staying only briefly, each one sending back tantalizing glimpses of what was there. The first of these was a small craft called Pioneer 11. It had been launched from Earth in 1973 on a long curving journey that took it first past Jupiter, where it borrowed a little speed from that giant planet, and then onward out through the cold, dark to Saturn. Pioneer 11 arrived in 1979 and made its closest approach to the planet in early September of that year. It was a small, simple spacecraft by later standards with just a few cameras and a few instruments. But it was the first object made by human hands ever to come close to Saturn. It flew within 21,000 kilometers of the planet's cloud tops, ducked under the rings, and sent back the first close-up photographs ever taken. They were grainy by modern standards, and the colors were uncertain, but they were real photographs of Saturn taken from nearby. People on Earth crowded around television screens and newspaper pages to see them, marveling at the soft, pale stripes and the great bright rings seen for the first time at close range. The next two visitors came not long after. They were called Voyager 1 and Voyager 2, and they were a great deal more sophisticated than Pioneer. They had been launched from Earth in the late summer of 1977 on a rare alignment of the outer planets that allowed a single spacecraft to visit several of them in turn by using each planet's gravity to slingshot onward to the next. Voyager 1 reached Saturn in November of 1980. It flew close to Titan, hoping to peer down through the orange clouds, but the haze was too thick, and Voyager could not see the surface. It did, however, confirm that Titan's atmosphere was thick and complex, and full of interesting chemistry. Voyager 2 passed through the system the following year, in August of 1981, and provided clearer photographs of many of the moons and of the rings and of the planet's pale storms. It was the Voyager spacecraft that first revealed the true complexity of Saturn's rings. Where earlier observations had shown only a few main bands, the Voyagers showed thousands of narrow ringlets, like the grooves on a record, like the rings of a tree cut crosswise. They photographed the strange dark spokes for the first time. They saw the twisting braided F-ring with its little shepherd moons, keeping it neatly in place. They flew past moon after moon, sending back images of worlds that had only been points of light to earlier astronomers. Mimas with its vast crater, Tethys with its long canyon, Iapetus with its strange two-toned face. Each new image arrived on Earth like a small wrapped gift, opened slowly, examined carefully, and treasured. The Voyagers, after Saturn, continued onward into the outer solar system. Voyager 2 went on to Uranus, and then Neptune, and Voyager 1 headed up and out toward the edge of the Sun's domain. They are still flying now, decades later, far beyond the orbits of any of the planets, drifting quietly through the dark space between the stars, sending back faint signals that grow weaker each year. They will continue on, long after they stop transmitting, drifting through the galaxy for billions of years, as quiet messengers from the small blue planet that built them. But the brief visits of Pioneer and Voyager only made the scientists on Earth want to know more. There was so much that those quick flybys could not answer. To truly understand Saturn, you needed to stay. You needed to orbit. You needed to spend years there, watching the seasons change, watching the storms come and go, watching the moons pass in their long, slow dances. And so, after many years of patient planning, a much grander mission was prepared. Its name was Cassini, named after the same Giovanni Cassini who had first noticed the gap in the rings more than 300 years earlier. The spacecraft, Cassini, was a robot, of course, an automated probe, but it was an extraordinarily capable one. It was the size of a small bus. It carried 12 scientific instruments, each one designed to study a different aspect of Saturn and its moons. It had been built by a partnership of space agencies in the United States and Europe and Italy, and it was launched from Earth in 1997, and it had spent 7 years quietly travelling across the solar system, taking long, careful loops around Venus and Earth and Jupiter to gain speed, before finally arriving at Saturn in the summer of 2004. When Cassini arrived, it slipped into orbit around Saturn and began the longest and most thorough study of any planet beyond our own that has ever been carried out. For 13 years, it circled the ringed world. It flew close to Titan more than 100 times. It dropped the small Huygens probe through Titan's orange atmosphere. It flew through the plumes of Enceladus. It photographed the rings from above and below, in every angle, in every kind of light. It watched storms grow in Saturn's atmosphere. It mapped the surfaces of moons whose names had only been points of light to earlier generations. It sent back hundreds of thousands of images and uncountable measurements, and many quiet decades of careful science to come. In the end, Cassini was running low on the small amount of fuel it carried. The mission planners had a choice to make. They could let Cassini drift, eventually perhaps crashing into one of Saturn's moons and contaminating it with whatever bacteria from Earth might have hitched a ride on the spacecraft. Or they could end the mission cleanly by sending Cassini into Saturn itself, where it would burn up safely in the planet's deep atmosphere. They chose the second option, and so on the 15th day of September 2017, Cassini took its final dive. It plunged into Saturn's clouds at tremendous speed, sending back data all the way down. It transmitted measurements of the atmosphere it was passing through layer by layer, until at last the heat and pressure became too great, and the spacecraft was torn apart, its various pieces vaporized into the very atmosphere it had been studying for so long. In a sense, Cassini became part of Saturn itself. The metals that had made up the spacecraft are now spread in trace amounts through the upper clouds of the planet. They will drift there for a very long time. The end of Cassini was a quiet kind of farewell. Many of the scientists who had worked on the mission gathered at the control center on the night of the final dive, watching the last signals come in. They had spent decades of their lives on this small robot. Some had begun their careers as graduate students working on Cassini and were now senior researchers with children of their own. Some had children who had grown up entirely during the mission. And now the spacecraft was coming to an end, drifting down at last into the gold-coloured clouds. There was a small countdown when the final signal was lost. There was a quiet round of applause. There were a few tears, gently shed. And then there was silence, and the long work of going through everything Cassini had sent back, which will continue for many years to come. We have learned much about Saturn from Cassini, much, but not everything. There are still mysteries about the rings, about why they exist, about how long they will last. There are still mysteries about the hexagon at the North Pole, about the storms that wrap around the equator, about the strange chemistry of Titan's atmosphere, about the warm ocean beneath the ice of Enceladus. Some of these questions will be answered by future missions. There are plans drawn quietly in laboratories and mission control rooms around the world for new spacecraft to return to Saturn one day. The most exciting of these plans, perhaps, is a mission called Dragonfly. Dragonfly is a small spacecraft currently being built and tested that is scheduled to be launched from Earth in the late 2020s and to arrive at Titan a few years after that. What makes Dragonfly unusual and what makes it especially exciting to think about is that it is a kind of flying vehicle, a drone. It will arrive at Titan, descend through the orange atmosphere, and instead of landing in one place and staying there, it will be able to lift off again and fly through the dense Titanian air and travel from place to place, exploring different regions of the moon. It will use 8 rotor blades like a small helicopter, only larger and slower. The thick atmosphere of Titan and the low gravity make flying easier there than it is on Earth. A vehicle that would struggle to lift its own weight in Earth's air can soar quite easily in Titan's, drifting from one side to another at a leisurely pace. Dragonfly will land first on the dunes near Titan's equator, and then, over the months and years that follow, it will hop from place to place, to a small ridge here, to the rim of an impact crater there, to different patches of ground where different chemistry is happening. It will sample the air at each new location and the surface, and look for the kinds of organic molecules that might be precursors to life. Titan, with its rich, complicated chemistry, may be a kind of preserved laboratory of the conditions under which life on Earth first arose. The same simple molecules that built up billions of years ago in the warm pools and seas of the early Earth are present today on Titan, in much greater quantities. Dragonfly will look at them up close in their natural setting, and what it finds may help us understand the story of how life began. There are other proposals being discussed too. A mission to send a small submarine into one of Titan's methane seas to drift on the dim, cold surface of Kraken Mare and explore what is below. A mission to fly a probe through the plumes of Enceladus more slowly and carefully than Cassini ever could, with instruments specifically designed to detect signs of life in the water vapor. A mission to drop a probe into Saturn's atmosphere itself, equipped to survive deeper into the clouds than Cassini's final dive ever managed, sending back information from layers of the planet that have never been directly examined. These are all expensive missions and complicated and slow to plan and build. They will take years, perhaps decades, to come to fruition. The scientists who first dream up such a mission may not be the ones who see the data come home. Some of them will retire. Some of them will pass away before the spacecraft has even left Earth. But this is how we have always done these things. The work is patient. It takes longer than any one human life. We build for the people who will come after us. We send small, careful machines out into the dark with instructions written by people who will not live to read what is sent back. And the machines, in their slow, patient way, do their work, and the data comes back, eventually, to a new generation of scientists who pick up where the old ones left off. But these are missions of the future, and the future is patient, and Saturn is patient too, and the rings will go on turning while we make our slow plans. Let us drift for a moment before we leave. Let us imagine that we are standing somewhere out beyond the rings, just floating in the dark, the way one might float on a still lake at night. The sun is very far away. From this distance it does not look like a great fierce ball. It looks more like a particularly bright star, small and pale, 100th as bright as it appears from Earth. There is enough light from it to see by, but not very much. The shadows are deep. The cold is profound, deeper than any cold that has ever touched the Earth. And there, in front of you, hanging in the sky, is the great gold-coloured world of Saturn. The bands of cloud are quite plain to see, in soft, horizontal stripes. The pale North Pole with its strange hexagon sits at the top, At the bottom, the South Pole has a great single round storm, an enormous swirling vortex, like the eye of a hurricane that has lasted for thousands of years. Around the planet, the rings spread out in a great flat plain, catching the distant light, glittering very softly in countless tiny reflections from countless tiny pieces of ice. You can see the dark gap of the Cassini Division cutting across the bright disk of the rings. You can see the broad shadow of the rings falling across the planet's cloud tops, a long, thin, dark band, like a stripe of paint laid carefully across the gold. Here and there around the planet, the moons drift along in their orbits. Titan is the largest, easy to see, a soft orange disk that shows even at this distance. Enceladus is a brilliant white pinpoint, with a faint plume of vapour catching the light like a tiny pale flag. The smaller moons are dimmer, but you can pick them out. Mimas with its great crater, Iapetus with its dark side and its bright side, Tethys and Dione and Rhea and the others, each one in its careful path. They move so slowly in their long orbits that you would have to wait for hours or days to see any of them shift visibly. But they are moving. Everything here is moving. In this great quiet system, nothing is truly still. There is a hush about the place. Not silence exactly, because there is no air to carry sound and no sound to be carried. Just a kind of vast emptiness in which the only motion is the slow, patient turning of the planet and the slow, patient turning of the rings and the slow, patient turning of the moons, all of it moving together as it has moved for hundreds of millions of years, as it will move for hundreds of millions more. If you stayed out here, drifting in the dark beside the rings, and you watched and watched, you would begin to see how slowly the system moves and how regular it is. You would see Mimas come around the planet in its short 22-hour orbit. You would see Enceladus a little further out in its 33-hour orbit. You would see Tethys and Dione and Rhea, each one taking a little longer than the last. Titan, the great orange moon, takes nearly 16 Earth days to make a single trip around Saturn. The far moon, Iapetus, takes nearly 79 days, and out beyond all of these, the small irregular moons drift in their long elliptical orbits, some of them taking years to make a single circuit. The whole system is a vast clockwork, with many hands moving at many speeds, all turning together around the gold-coloured planet in the middle. It is a kind of timepiece, in fact, in its own way. If you knew the exact positions of all the moons at one moment, you could calculate, with the help of patient mathematics, where they would be 1,000 years from now, or 10,000 years, or 1,000,000. The orbits are so steady, so well behaved, that they make the running of the most precise clock on Earth look slipshod by comparison. Saturn is a clock that has been running for billions of years, with no one to wind it, no one to reset it, no one to do anything to it at all. It simply runs, and it will go on running long after the current generation of scientists who study it has passed away, long after our species has changed beyond recognition, long after we are gone entirely from this small blue planet of ours, whatever becomes of us. Saturn will still be turning, the rings will still be glittering, the moons will still be drifting in their patient orbits. There is something quietly comforting about this. The universe is not a fragile place. It does not need our attention to keep going. It does not depend on us for anything at all. We can rest, and the universe will keep turning. We can sleep, and the planets will go on with their orbits. We can lay our work aside just for tonight, and not a single thing in the wider cosmos will be affected by it. The great gold-coloured planet will not notice. The rings will not pause. Titan will not stop its orange skied weather. Enceladus will not stop sending up its plumes of vapour. Everything will continue exactly as it has always continued, while you let yourself drift towards sleep. The first humans to see Saturn, the ancient sky watchers in their gardens and rooftops, never imagined any of this. They could not have known about the rings or the moons or the hexagon or the methane lakes of Titan or the hidden ocean of Enceladus. To them, Saturn was a single small light, drifting slowly against the stars, and they named it after the slow god of harvests and time. And in a way, the name still fits. Time is what Saturn has, in great quiet abundance. The planet does not hurry, the rings do not hurry, the moons do not hurry, they turn at their own pace, and they have all the time there is. You too do not have to hurry. There is no place you need to be tonight. There is no thing you need to do. You can drift for a while in the soft, pale gold of Saturn's clouds, in the quiet glitter of the rings, in the patient orbits of the moons. You can let your thoughts go a little soft. You can let the day slip away from you the way a small, smooth stone slips away into a deep pool of water. You can rest. Soon the soft gold of Saturn will fade gently around you. Soon the rings will grow dim, and the moons will draw away into the dark, and the great patient planet will recede, the way a candle in a far window grows smaller as you walk further down the road. Soon you will not be in space at all, but back in the warm, familiar room where you are resting tonight. Your breath will be slow, your shoulders will be soft, your hands will be still, and sleep will be very near, if it has not already arrived. There is no need to follow the rest of the words. There is no need to think about Saturn any more tonight. The planet will keep on turning, whether or not you are awake to remember it. The rings will keep on glittering in their long, slow circle around the gold-coloured world. The moons will keep on drifting in their patient orbits. Titan will keep on raining its soft methane rain. Enceladus will keep on quietly venting its bright plumes into the dark. The hexagon will keep on tracing its careful six-sided shape at the top of the world. None of it needs you to watch. All of it has been doing what it does for a very long time, and will go on doing what it does for a very long time more. So you can rest now. You can rest your mind. You can rest your body. You can let go of the day that is behind you, and you do not have to think about the day that is ahead. Both of those are far away, like the Earth is far away from Saturn, like the sun is a tiny pale star in this distant cold place. They cannot reach you here. Nothing has to reach you here. There is only the quiet and the soft gold of the rings, and the long, slow turning of all things, and the gentle drift of your own breathing, in and out, in and out, in and out. Saturn will be there tomorrow night, and the night after, and 1,000,000 nights after that, when you are not even thinking about it at all. The slow god of time has not forgotten his name or his quiet work. He keeps the harvest. He keeps the years. He keeps the long, unhurried turning of everything. And tonight, just for a little while, he will keep you too gently in the soft, pale circle of his arms. And so we leave him. We leave the rings and the moons and the gold-coloured clouds and the slow turning and the patient hexagon at the top of the world. We drift back, gently, the way a small boat drifts back to a quiet shore, back across the dark, back past the orbits of the outer worlds, back toward the small blue planet that is our home, back toward your own small warm bed, in your own small warm room, on this small warm world. And here you are, and here is your pillow, and here is your blanket, and here is the soft, slow rhythm of your own breath, in and out, in and out. Rest well, sleep well. Nothing more is needed of you tonight, only rest, only sleep, only the quiet drifting of a mind that has wandered far and now comes home again and lays itself down to dream. Good night.